Hello students, welcome back to today's class on integers, and today we're going to discuss properties of integers. For any topic, anywhere, any chapter, properties are very important when you're learning the subject. So in today's class we'll try to discuss about properties of integers. But before that, in the last class after discussing multiplication, we didn't discuss division of integers. So let us try to cover the division of integers and then move to the properties of integers, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So in the last class when we were discussing about multiplication, I told you a few things about the signs, how the sign will change to positive or a negative. When you have a negative, even number of times, you will get positive. When you have negative odd number of times, you will get negative. Odd number of times you get negative. Okay, minus 3 into some value will be 27. I know that 3 into 9 is 27. We know that. We know 3 into 9 is 27. The point here is minus 3 into which value will give 27, that's okay. But what is that sign we need to discuss? If you have only one negative, which is odd number of times, your final answer should be negative, but your final answer is positive. Your final answer is positive, so definitely you should have two negatives. Minus 3 into minus 9 is equal to 27. Minus 3 into minus 9 is equal to 27. The next point is 5 into which value gives you minus 35. First of all, leave that negative. You know that 5 into 7 is 35, correct? What is that negative value now? Here we have negative, so one out of these two should be negative. So 5 into minus 7 is equal to minus 35. 5 into minus 7 is equal to minus 35. Okay, next, which number into 8 will give you 56? 7 into 8 is 56. 7 into 8 is 56. So you have a negative here. It is enough to say that the number is 7. No need to keep one more negative, right? Here 132. So 11 into 12 is 132. 11 into 12 is 132. You have positive. Positive means you should have at least two negatives. If you have one negative, that will not work. We need to have two negatives. So one is minus 12 and one is minus 11. So minus 11 into minus 12 is equal to 132. Minus 11 into minus 12 is equal to 132, correct? Okay. So let's move forward for the next one. That is a division of integers. And the sign scheme, the positive and negative changes, wherever we are having the multiplication, the same properties, the same kind of calculations will appear in division. That means when you're dividing two positive numbers, just like multiplication of two positive, you will again get a positive number. But if you have one positive and one negative, so you'll get a negative. Multiplication also we are getting the same thing, right? Negative divided by positive, that is also negative. Negative divided by negative, that is very important. Negative divided by negative, just like negative into negative. Negative into negative is positive. So negative divided by negative is also positive. Okay, this last thing is very important. Just like multiplication, negative into negative is positive. In the same way, negative divided by negative is also positive. Okay. So the next one, 100 divided by 5. These are all the general positive numbers. What is 100 divided by 5? 20. 100 divided by 5 is 20. 81 divided by 9 is 9. 125 by 25 is 5. 80 by 5 is 16. 64 by 16 is equal to 4. Okay. So all these numbers, all these calculations are easy. Just straightforward, positive numbers. But now, we need to discuss with negative values also, correct? So let us try to discuss with negatives. We have one negative. We have negative by negative divided by positive. Negative divided by positive. Positive by negative. Positive by negative. Negative by negative. So we have different combinations, okay? First thing, you try to understand all this. Positive by positive is positive. All these values are positive, correct? Positive by negative, positive by negative, positive by negative will give you negative. So these two are negative values. Okay, we'll come back to that. Don't worry about this. In the same way, negative by negative will give you positive. So this is a positive answer. So in that way, let us try to discuss the answers for this one. Same values, right? All these are same values, but the only point is plus or minus is the difference. So minus 100 divided by 5 is 20, the same 20. As we have one negative, it is minus 20. Minus 81 divided by 9, it is again the same 9. As we have one negative, keep it minus 9. Next, 125 divided by minus 25, so that is again 5. That is again 5, 125 divided by 25, and we have a negative, so keep it negative. 80 divided by minus 5 is minus 16. 80 divided by minus 5 is minus 16, correct? 64, minus 64 divided by minus 60, you have two negatives. Now, negative divided by negative will give you positive. So that is a plus 4. Negative divided by negative is a plus 4, correct? Okay, so let's move forward for the next point. So that is about, division is done. So the next one we're going to discuss about properties. I told you properties are very, very important in any chapter, anywhere, in any subject. Here we're trying to discuss all the properties of integers. Okay, so the first one we're going to discuss is closure property. What is closure property? For example, you are taking two numbers a and b. Let us say both are integers. So now I want to apply some operations on that, like a plus b, a minus b, a into b, and a divided by b. A divided by b. Addition, subtraction, multiplication, division. And I want to check whether I will get again the answer as integer or not. The first one we are going to discuss with addition. Okay, you can see that when we're trying to discuss a and b as an integer, I want to check whether a plus b is also an integer or not. I want to check whether a plus b is also an integer or not. Let us try to take one value, 6 plus 30. Okay, what is 6 plus 30? 36. 6 plus 30 is 36, which is a sum, right? Again, the sum is an integer. It is an integer. I want to verify that a plus b is also an integer or not. Yes, I got an integer. But let's try to have different cases, positives and negatives. Minus 5 plus 10. I told you whenever you have one negative, just find the difference. 10 minus 5, 5, and keep the sign of the highest number, the greatest number. Between 5 and 10, the greatest number is 10, so that 10 is positive, so plus 5, which is an integer. Right, so this is also an integer. Minus 9 plus minus 11. Minus 9 plus minus 11. Both are negatives. Just add normally 20 and keep negative. Is that an integer? Yes, minus 20 is an integer. 61 and minus 3, which is 58. 61 and minus 3, which is 58. Okay, positive or negative, keep the value which is greater, which is greatest sign. Sign of the greater number. 61 is positive, so you'll get a plus 58, which is again a positive. Right, a plus b, okay, a be an integer, b be an integer, a plus b is also an integer, so I can say that yes, a plus b is also an integer. So how can we conclude this? We can conclude that integers are closed under addition. Integers are closed under addition. That means they're obeying closure property, they're following closure property when we are trying to operate under addition. Okay, when we are doing addition of numbers. So this is all about addition. Let us try to discuss same closure property with subtraction, and then multiplication, and then division. So let's move forward to subtraction. For any two integers a and b, a minus b, I want to discuss about a minus b, whether it is an integer or not. Whether it is an integer or not. Let's try to take a few values. 30 minus 6, you know it is 24, integer. Minus 5, minus 10, both the negative values add and keep a negative. 5 plus 10 is 15 and keep a negative integer. Minus 9, minus of minus, I said you, when we are multiplying, minus of minus will give you positive. So minus 9 plus 11, which is a 2, yes, it is an integer. 61 minus of minus 3, 61 plus 3, 61 plus 3 is 64, which is again an integer. A minus B for any two numbers, we can see that, yes, it is an integer. So once again, what I can say? That they are obeying closure property. Okay, integers are closed under subtraction. Integers are closed under subtraction. Right? The before slide, integers are closed under addition. Here it is closed under subtraction. Okay, so let's move forward for the next one. Now we are going to discuss the same closure property with the multiplication A into B. With the multiplication A into B. So how can we see this one? Let us try to take different values of A and B. Right? 6 into 30. 6 into 30. It is 180. Is it an integer? Yes. Minus 5 into 10. Minus 50. Minus 5 into 10. Minus 50. It is an integer. Minus 9 into minus 11. So plus 99. Why plus? Negative into negative will give you plus. Okay, positive. It is an integer. 61 into 3 becomes 18 and 3, 183 with negative. Yes, it is an integer. So I can say that A into B is always an integer. So what I can say with the closure property now? Okay, integers are closed under multiplication. Integers are closed. That means they are obeying closure property when we are trying to multiply two integers. When I say integers, you can also take positive, you can also take negative, positive, negative, 0 and negative, 0 and positive, whatever combinations are. Right? You can go with this one. 6 into 0 is 0. Yes, it is an integer. Minus 6 into 0, 0, it is an integer. Correct? Positive and negative everywhere. When you are multiplying with 0, you get the answer 0, which is again an integer. Which is again an integer, right? Okay. Let's move forward for the next one. That is A divided by B. And I'm telling you once again, division is very, very crucial. It may give you wrong answers. You may be confused with division. In all the properties, not only here, in all the properties. After this closure, we'll discuss commutative, after that associative, right? You should always be very sure, very cautious with the division sign. Division property, okay? So let us try to take few numbers. 30 divided by 6 is 5. Yes, it is an integer. Minus 5 is an integer, 0 is an integer, minus 5 by 0, which is undefined, it is not an integer. It is not an integer. It is enough to say that this is wrong. A plus B is also an integer is wrong. A plus B may or may not be an integer. It's not always true because it is not true. Okay, you may say that, sir, only with 0 it is happening. Let us try to take some more values. Okay. Minus 9 divided by minus 11. So you'll get 9 by 11. Both the negatives gets cancelled. 9 by 11 is not an integer. 61 by minus 3 is not an integer. So A divided by B may or may not be an integer. May or may not be an integer. So we can say that A divided by B is not. Okay, it's not correct. It's not an integer. So it is not obeying closure property when we are going with a division. Integers are not closed. Integers are not closed under division. Right? So once let us try to have all these four formulas together. Under addition, we are going to discuss with closure property. Yes, it is true. Multiplication, it is true. Subtraction, it is true. Division is false. Division is wrong. It is not obeying that, right? Integers are closed under addition, multiplication, subtraction, but not under division. Understand? So, as we have discussed a lot of things about closure property, let us try to move towards the next property, which is a commutative property. And in the commutative property, as you can see here, we are discussing about two values, a plus b and b plus a. We are trying to compare two quantities, whether they are equal or not. What are a and b? A and b are any integers, positive, negative, 0, whatever it is. A plus b and b plus a, are these two equal when you are doing addition? Same way, next subtraction, next multiplication, next division, and let us try to see what all operations can be satisfied with commutative property. Right? So now let's take two numbers and add them, all different combinations. Let's try to take 6 plus 30 is 36, 30 plus 6 also 36. So are these two equal or not? Yes. You know that from the childhood, when you're learning all the numbers, 1 plus 2 or 2 plus 1 will give the same answer, 3. Right? Minus 5 plus 10, 10 minus 5 or minus 5 plus 10. So which is correct, which is wrong? Are these two same? I told you. Whenever you have one negative, just find the difference of these two, 5, and keep the sign of the highest number. 10 is positive, so keep plus 5. 10 minus 5, 5. So both are same. Minus 9, minus 11, minus 20. Minus 9, minus 11, minus 20. Minus 11, minus 9 is again minus 20. Both are same. Both are same. What about this one? 61 minus 358. 61 minus 358. Minus 3 plus 61 is also 58. Right? The highest number is 61. So it is positive. So keep positive. So again, both are same. So a plus b and b plus a, are these two equal? Yes. A plus b is equal to b plus a. So the given relation is correct. Okay. So it is a true always. We can say that commutative property is close, or it's valid for addition. We can say integers are commutative under addition. Commutative under addition. A plus b and b plus a, are these two equal or not? We verify it is equal. In the same way, let us try to discuss same property with subtraction. And again, I'm saying subtraction and division are very, very important. They always confuse and will give you wrong answers. So a minus b and b minus a, are these two equal or not? We need to verify that. A minus b and b minus a. The point here is, let us try to take two values. 30 minus 6, it is 24. But 6 minus 30. In 6 minus 30, what will get? 6 minus 30. Okay, the difference is 24, correct? But 30 is highest, minus. So you'll get minus 24. So are these two same? Minus 24 and plus 24, are these two same? No, these two are not the same. Done. It is enough to say that a minus b is not equal to b minus a. But okay, let me say that only for one case. Let us try to take different values. Okay, what is the second example? Minus 5, minus 10, both the negatives. Just keep on adding and keep the negative. Minus 15. Negative of negative, I told you it is positive. In multiplication, negative of negative, negative into negative is minus, is positive. 10 minus of minus 5 is a 10 plus 5, which is 15. 15, which is again false. Here it is minus 15, it's not 15. Minus 15 and 15 both are not equal. So that's the reason the cross symbol came here. Okay, so minus 9 plus 11, 2. Minus 11 plus 9, minus 2. Both are wrong. Both are not the same. You can also try with the next one. So what I can say, a minus b and b minus a are not the same. So I can say that a minus b is not equal to b minus a, and we can say they are not commutative under subtraction. They are not commutative under subtraction. So please try to remember that. It is valid for addition, but it is not valid for subtraction. First we discussed closure property, and now we are discussing commutative property. So don't get confused between these two. Don't apply one relation with the other relation in two different properties. Okay, so what is the next one? We're going to discuss the same property with the multiplication. A into b and b into a. A into b and b into a. So what we can see here, 6 into 30 is 180. 6 into 30 is 180, and 30 into 6 is also 180. So in this case, I can say that both are same. But what about the next one? Minus 5 into 10. Minus 5 into 10. So what I can say, it is a minus 50. Minus 5 into 10 is minus 50. 10 into minus 5, 10 into 5 is 50. Again, you have one negative, that is also equal to minus 50. Both are same. How we can say that? When you have one negative, just keep the same negative outside, multiply the numbers. Right? What is the next one? Minus 9 into minus 11. Negative into negative, I told you it is positive. Negative into negative is positive. So 11 into 9 is 99, or 9 into 11 is 99. Both are positives, both are equal. Next one, 6 into 3 is 18 with a negative. So minus 18, minus 3 into 6 is again 3 into 6 is 18 with a negative. So yes, these two are same again. So what I can say, A into B and B into A, always these two will be equal. And I can say that yes, A cross B is equal to B cross, or A into B is equal to B into A. From there I can say that multiplication is true. I mean to say, commutative property is valid with multiplication. Okay, commutative under integers are commutative under multiplication. Integers are commutative under multiplication, right? So one last thing we're going to discuss for today is a division. Division of integers, same commutative property with the division. So what we can say here, when we have two numbers, we need to verify whether A divided by B and B divided by B divided by A, are these two equal or not? Are these two equal or not? So what I can say here, 6 divided by 30, 6 by 30, which is 1 by 5, and 30 by 6, 30 by 6, which is equal to 5, both are not the same. Both are not the same, correct? Minus 5 divided by 10 and 10 divided by minus 5. Minus 5 divided by 10 and 10 divided by minus 5. So minus 5 by 10 is minus 1 by 2. 10 by minus 5 is minus 2. Are these two equal or not? Minus 1 by 2 and minus 2, these two are not the same. So in the same way, you can also verify the remaining two. You can also verify the remaining two. Remaining two also will give you the wrong answers, right? You can verify that. So what I can say finally, A divided by B and B divided by B divided by A, both are not the same. So A by B is not equal to B by A. So what I can say here, again in the division only we got this difference. Okay, division is very confusing always in properties. So integers are not commutative under division, not commutative under division, right? So let us try to have all the four at once. In commutative property, addition is correct, multiplication is correct, subtraction is wrong, and division is also wrong. What I can say, integers are commutative under addition and multiplication, but not under subtraction and division. Subtraction and division, right? So I hope you understood all these topics. We have discussed about commutative property. We have discussed about closure property. I mean to say commutative and closure property. I hope you understood all this, right? So that's all for today's class, and we'll continue with the next class with some more property, that is associative property. The next class we are going to discuss about associative property, and after that we have a couple of more properties also. So all these we're going to cover in the next class, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So today we'll be discussing about rest and motion. Okay, so my name is Shashin Reddy. I'm a graduate from IIT NEET. So let's start the class. So when we talk about rest, what do we actually mean when we say that a body or a particular body is at rest? Look at this, for example. Here we have a few books, 4 books exactly, 4 books placed on a table. Generally, when we look at them, we say that these books are at rest. So what do we mean? When we say something is at rest, for us, its position is not changing. It is not moving. Right? Its position is not changing. So that's what we say, that's what we call a body at rest. Body is said to be at rest when its position with respect to its surroundings does not change. See, look at this. Does not change. What does not change? Position with respect to surroundings does not change with time. Simple, right? Or else if the position changes, I mean, see, I've been walking. So my position is continuously changing when I walk. Right? Even very slowly, even very small, but my position is changing when I am walking. Yes. So am I at rest? No, not at rest, because my position is changing. But look at the screen. Is the screen moving? No. The screen is at rest. Yes or no? This complete screen is at rest because it is not moving. That's what we mean when we talk about rest and motion. Clear? Okay, just a minute. So when we want, what does motion mean then? It's very simple. Its position changes with time. So whenever a body's position changes with time, we say that that object is in motion. For example, you can see a tiger. That's a tiger, right? So a tiger running, and the position of the tiger is changing in the animation. The tiger is in motion. Tiger is in what? Tiger is in motion. Simple? Yes? Okay. Now, there are some important properties, always understand. Whenever you look at something and we say something is at rest or something is in motion, that is relative. What does that mean? I'll explain. Look at this. Here, look at this camera. When we look at this animation, we feel that this particular side is at rest. This side, the left side. And the trees are appearing to go back. Now, does that actually happen? And where have you noticed this? In everyday life, whenever we are traveling in a car or any vehicle, we notice this. Yes or no? So this is a car. You can clearly see that car appears to be at rest. The trees are going back. The trees are traveling. Trees are moving. But does that happen? No. Trees are at rest, but we or the car will be in motion. Yes or no? So whether the tree is at rest or the tree is in motion depends on person to person. So on which person? I'll take a simple example. Let's say this is a road. And let's say there is a car. And inside the car, let's say there is a person. I'll call that person as A. Now outside the road, just besides the road, there's another person B. Now there is a tree here. There's a tree. So here for A, or according to A is in the car. And let's say car is going to front, car is going towards the right. So when the car is going towards right, the person A will also be going towards right. So for the person A, tree will be going back. Tree will appear to move back. Yes or no? Tree will appear to move back. But what about for person B? For person B is just standing. Person B is just at rest. He or she is at rest. That's it. They're not doing anything. They're just standing. So for this person B, for B, tree is at rest. And you see that here the same tree is moving back for A but is at rest for B. The same tree. Magic? No. It just means that motion is relative. What does relative mean? Motion depends on who is watching, who is observing. In the first case, when I say for A is observing. When I say for B is observing. So what is different here? Observers are different. The one who is seeing is different. The one who is watching is different. Clear? Yes? So, another example. Similar one. You can think of it as a train or a metro, right? A train. So, train is traveling and you can see buildings are moving back. See? See here. The buildings are moving back. Do the buildings actually move back? No, they don't. Buildings don't move back. They appear to move back because here, according to this, we are in the train. So for a person in the train, the buildings appear to move back. But for a person standing outside on the platform of the train, buildings will be at rest. So again, motion is what? Relative. It depends on who is watching. Who is observing? Depends on the observer. Clear? Understood? So an object can be in motion relative to one set of objects, one type of objects, one case of observers, while at rest relative to some other set of objects. It depends on which object is observing. Clear? Okay. Now for example, the best example is this, one of the simple examples. Now look at this girl here. This girl is happily sitting on a sofa. Happily sitting on a sofa. Now if you ask the room or the sofa, if you ask the sofa what? Sofa, is the girl at rest or is the girl moving? What are you asking sofa? You're asking sofa, is the girl at rest or in motion? What will the sofa say? The sofa will say, the girl is just sitting happily. She is just at rest. Sofa will say that the girl is at rest. But if you ask the same question to sun, to the sun, exactly, the sun. What does the sun say? The sun will say, the girl is moving along the earth. And what is earth doing? Earth is revolving around the sun. So when you ask the sun, is the girl at rest? The sun will say, no, the girl is not at rest. The girl is what? The girl is revolving around me, around the sun. Understood? Simple example. For the sofa, the girl is at rest, but for the sun, the girl is moving along the earth, revolving around the sun. Understood? Right? So again, a simple case. Depends on whether you are at rest or not. Depends on the observer. Okay? Understood? Very simple example. Clear? Okay. So that's it, everyone. That's it for today's class. See, rest, we learned about rest and motion, and that rest and motion are relative. Very simple. Okay? Thank you. Thanks a lot.